So question answering, it's a very quick topic. Nothing too much to dive into. So first of all, just a quick recap we have done. We have studied about attention networks. Just give me a second. Okay, so there are three ways of attention. We have seen machine translation, which is encoder decoder attention, where we have one sentence decoder and which looks at the another sentence encoder. So suppose I have English sentence and a Hindi sentence, and I'm translating from Hindi to English or maybe English to Hindi. So if I'm translating from English to Hindi, so Hindi sentence, each and every word in the Hindi sentence will look up to all the words in the English sentence, that is the input sentence. So each and every word in the output sentence will look into all the words for the input sentence. For example, uh, suppose three words were there in the input sentence and three words were there in the output sentence. So this will look up to all the three words in the encoder part. So this is encoder and this is decoder part while translating. So this is encoder decoder attention. Next is causal attention. It's also called self attention. And in self attention, if I'm predicting, suppose I'm generating the text or maybe text summarization or some kind of application where I'm generating the next word. So in those kind of applications, suppose I was predicting this word happy, then I want to predict this next word am. So for predicting the second word, I will look up to happy. So whatever the words that were previously already generated, we will look at all those words in the same sentence. So that is self-attention. Bidirectional attention we have seen in BERT and ExcelNet, where we have some words that are masked out and we predict those words. Simultaneously, we look into the both directions, previous words and the future words, and that is called bidirectional self-attention. Okay, so three ways. Then we have also studied multi-head attention, where we look into multiple heads in a transformer. Okay, example of causal attention. Now, the only difference in the self-attention and the encoder-decoder attention is that when we multiply query, suppose this was the input sentence and this was the output sentence. Suppose it was having four words. So this would be my query, and I will multiply with all the key vectors over here. So this q1 will be multiplied by k1. This q1 again will be multiplied by k2 for second word. This q1 again will be multiplied by k3. I will get k cross q vectors query with respect to key vectors. Then I will apply a softmax over this, right, to get the probability. And it would be something like 0. If this word was similar to first word, so I will get 0 0.8, 0 0.1, 0 0.1. So this would be higher. And then after I apply softmax, what I will do is I will multiply it with the value vector, which is so I will get a weighted sum of all these key query values as attention. Okay, so this I will repeat for all the words in the decoder. So the only difference in the self-attention with respect to the attention that I have is in self-attention, instead of multiplying this output, this query value, because query in case of encoder and decoder one, so query was the part of the decoder, but in self-attention query would be the part of input sentence. So here in the prediction part, suppose this is the whole sentence. So and this would be my query. So I will multiply this query with all the keys k1 k2 up to kn that I have seen already. So the only difference is that query vector changes from output to the word itself, in the same sentence. So this is the difference. Then we have looked at a transformer in the last turn. Again, just a quick recap. And in transformer, what happens is, again, we have inputs, that is embedded vectors. Then we have positional encoding. So can anyone of you tell me what is positional encoding and why do we do this? Okay, transformer is very important topic. Study this. So positional encoding is because in multi-head attention we give all the data as input parallelly. Okay, all the heads are run simultaneously. So if I'm generating vectors with respect to 4 words, so I'm giving all the data as input in parallel. So I don't know which word was coming first in the sequence and which was coming on the second position in the sequence. So to restore the information about the positions of these words, we apply positional encoding. Then we have multi-head attention. So we have seen this in the last one. Then we have add and normalization. So this is nothing, it's just normalization, simple normalization that we do on the linear layer. Why do we normalize? Because we have studied in deep learning, because it normalizes the distribution of intermediate layer so as to get the smoother gradient or better generalization. So we will do normalization, and this is a there is one residual connection. This also we have seen in the deep learning, like we this is similar to ResNet, where we have residual connections, or we can also call that we also call this as skip connections. So we have residual connections, then we have feed forward, then we have again additional. This is for add and normalization. This is again for this one, and this one is for generalization, because we don't want our data to overfit, we don't want performance to degrade, and so many other things are there. We want to better generalize. So many things are there. Then we have a linear layer and we have a softmax. So this is what this was our decoder. Then we have encoder, work similar way. So this is encoder part. So here we will apply after over here decoder part. So these two work in a similar way. Next is, so let's come to question answering. So question answering is nothing, it's just the application where what we always do is we just train on the data set and we want some specific output. So in case of question answering, input is question and we want answer as output. Along with the question, we give context of the question as input. So this is our input and this is our input, and output is our target. So so for example, what percentage of French population today is non-European? So we need to have a look at the context paragraph and we need to find out the answer. So we will train on all the question and context data set and target as well. And then in the predict, and while predicting, we need to generate the output target. Okay, simply this is the case, simple prediction problem with two things as input. In addition to your question, you will also give your context as input. Okay, so the steps that you will follow to implement question answering. Load a pre-trained model. You can also use pre-trained rates. Any model you can use. You can use transformers. Process GPT. You can also use that. Then process data to get the required input and outputs. You have question, context as input, and A as target. Fine tune your model on the new task and input, and predict your own model. So predict using your own model. So this is these are the steps that you need to follow for a question answering kind of thing. So any doubts up till now, anything that was not clear? No doubts? Okay, so can anyone of you tell me what is the disadvantage of question answering? A disadvantage of this model? Okay, so this is example of question answering where you have a Stanford question answering data set given a paragraph P, that is your context, a question Q, and you need to find the answer as a subset of P. Okay, start as well as start and ending character, of course. So, so suppose question was, when did 1973 oil crisis began? And the ground truth answers were these. Okay, so when was second oil crisis? So basically they are just asking and simply generating the result. This is a simple example. The problem with this is, limitation with this is, answer is always in the paragraph. So this is a bias. Why? Because you are if you ask when kind of question, so if there is a single date in the text, it must be the answer, right? So generally it generates too many false positives. So this is the limitation of this kind of setting. So suppose you are training your model and you have a question like when, so they are just saying question like when, or maybe you are you have a question like where, and there is an address in the paragraph. So definitely, so answer would be that. So because while training you have seen everything, so this is kind of bias in the model, right? So this is the problem, this is the limitation of question answering. So what do some people do to remove this is, instead of instead of directly training on the question answering, what they do is they decide whether the answer is in the paragraph or not. So if so they will also predict yes and no. Yes, the answer is in the paragraph. No, the answer is not in the paragraph or the context that you have provided. Okay, so if the answer is yes, so it will extract the subset of that paragraph, and if the answer is no, it will proceed. It will say, okay, no, answer was not in the paragraph. It will not predict anything. Okay, so so this is another setting where you can, along with the answer, you can decide, you can add one more neuron which can predict like yes or no. Yes, the answer was in the paragraph, and no, the answer was not in the paragraph. So this is even a bit difficult, but it's more usable in for practical applications. So generally we do add one more neuron saying yes or no, answer was there or not there. Okay, so this is a simple setting, practical setting, where you can use transformers. You can, so you need to pre-train on the general text, so that is your already defined models. Then you need to pre-train your model again on your data set. Plus, then you need to fine tune your model for the classification. So this is the best approach that you can follow for training a classifier with the transformers. So that's it. This was simple question answering session. Uh, Anything, any doubts?